waves. In order to do that, we must start by talking about light. So we need to figure out, is light a particle or is light a wave? So believe it or not, light can serve as both or behave as both, a particle and a wave. So when it's behaving as a particle, it's known as a photon. Photons are found in space. Their energy depends on frequency. We'll talk about frequency some more during this video. And then it could also behave as a wave. Waves are found on Earth. They travel from space through the electromagnetic spectrum, which you should be familiar with at this point. So electromagnetic waves themselves are created by a vibrating electric charge which travels through space through the electromagnetic spectrum. So the properties of a wave include frequency, which we were just speaking of. So frequency is the number of vibrations per 1 second measured in hertz. The symbol for hertz is capital H, lowercase z. And then we have wavelength, which is represented by the Greek symbol lambda. It's the distance from one crest to another, and it's measured in meters, which is a symbol of lowercase m. An important relationship to remember, as frequency increases, the wavelength is going to decrease, and the reverse can be said, which means that as frequency decreases, the wavelength will increase. So if you look at my little diagram here, I have my waves really close together right here, which means that there's a high frequency, which means as a result there's a low wavelength. And as you travel through the diagram, you see the waves start to space out, which means there's a low frequency, but there's a high wavelength. So the relationship between frequency and wavelength are inversely proportional, or it means that they're the opposite. So let's talk about parts of a wave, and some of you may be familiar with this. So the crest is the maximum amount of positive or upward movement from rest. So that is what most of you would probably just call the peak. So each of those peaks is a crest. The trough is the maximum amount of negative or downward movement from rest. And these would represent your troughs right here. So amplitude is actually the distance from rest to the crest, which is better known as the wave height. So this is our amplitude right here, and we can measure the amplitude of each wave. I also put in this diagram up here wavelength. So remember, wavelength is the distance from one crest to the next, so that's why you see the double arrow. And then frequency is the amount of cycles per second. So here I have the numbers 1, 2, and 3, so that means we would have 3 cycles per 1 second, or for every 1 second. So wave speed. So electromagnetic waves travel in a vacuum, which means they have no gravity or force exerting upon them. And it travels in this vacuum at a speed of 300,000 kilometers per second. So they actually slow down as they travel through matter. So glass would be an example. Actually traveling through the atmosphere is an example of the wave particles traveling through matter, which is going to slow them down. And then we have our wave calculations here. So in order to calculate a wave, you must know the speed of light, which, if I'm not mistaken, is 2.99 times 10 to the 8th power. And then you have your equivalency of a wavelength multiplied by frequency. So remember, the wavelength is the symbol of lambda, and frequency is the lowercase v. And speed of light is measured in meters per second. So what's going to happen, the meters, remember, this is your dimensional analysis. Your meters are going to be the numerator here, and cycles are going to be the denominator. This is going to be multiplied by cycles per second in order to get rid of cycles, because we want our answer in meters per second. So if you see here, meters is not canceled out, seconds are not canceled out, so those are the units that are going to be left at the end. So now that you know about the electromagnetic wave, you know whether light acts as a particle or a wave, you can actually calculate waves for yourself, and that could be calculating the speed of light or rearranging this formula to determine the wavelength or the frequency. So good luck.